Good morning. Welcome to Montreal. Welcome to the first session, first day, Detnet. Hopefully we're all in the right place. So this is a little bit of an experiment. We're running from the IETF provided Chromebook. Hopefully that'll go smoothly, but if it doesn't, just bear with us. I'm Lou Berger. We have Janos Farkas here next to me. We have a couple of changes on the secretary side. I think we previously talked at the previous meeting about Ethan Grossman volunteering to be a secretary. So he's here. Really appreciate his help. And Yoni was our secretary from the beginning. He had a sort of a position change, which means that he's no longer regularly coming, so that's prevented him from continuing that role. We appreciate his service to us, and he's now going to be faded off, and actually is officially no longer secretary, so it's just Ethan. Thank you. Our slides and agenda are in the usual place. If you look at the agenda, you'll see it right at the top. There's a link to take you over to Etherpad. Please jump on that and help us out. I'll mention that a couple of times. Since it is the first session of this meeting, it's good to note our note well. It changed at the last meeting. There's been no change this meeting. The key thing to take away is that anything you say here in the working group, anything you say on the list, anything you say publicly becomes part of our permanent record that's available to all. Please feel free to look at that link, IETF.org, about Note Well, if you're not familiar with this, and it's a good thing to just know that it's sort of the ground rules by which we operate. We have video recording. We also have audio and Jabber. We've been doing a joint note-taking via Etherpad. Please jump on that link. It's really helpful to get as many people contributing to that. Also, if you do speak at a mic and want to make sure that your name is captured properly, as well as that your comment is captured appropriately, you can immediately go in and make sure that the notes are right. And that's really helpful, particularly on the names. And I do remind everyone to speak their name clearly when they come to the mic so that we can get it into our minutes. Our agenda was posted. We made one adjustment. The last presentation, number 10, is really a second half of number 6. So we've moved that up, so it's a 6A. And we'll take it in that order. As is always the case in the IETF, it's really important to use the list. And that's ultimately where our decisions are finalized. And we would like to remind people to raise new topics on the list, socialize your draft there. If you submit a new draft, please make sure to just let the list know what it's all about in a brief summary and get some discussion going there. We do allocate time in this room relative to list discussion. We follow a process that other working groups follow as well, which is before adopting a new working group document, as well as before progressing to publication request, we do a public IPR call and ask that all authors and contributors respond and do so in a timely fashion. If you don't respond, it slows the process down. So where do we stand in terms of our documents? We have 2 documents that are post last call, use cases and problem statement. The use cases document is ready to go. The main reason I'm the shepherd on it, the reason I haven't hit the submit is I'd like to time it to go forward with the architecture document. I'm just waiting for that. The problem statement, I think there was one more change that needed to be made.
Yes, there is one small item to fine tune. Otherwise, it's ready to go. Maybe we will send it as well together with the architecture.
So certainly we expect that these documents to move forward in pretty short order and well before the next IETF. The architecture document, we had some discussions and ended up with enough technical changes that we wanted to do a second last call. Because of the timing of the meeting, we did an extended last call, so a 3-week last call. That last call ends on Friday. This is on the agenda today, and they'll review the changes as well as any planned additional changes. We have several working group documents on the agenda. You'll note that the solution documents, data plane solution documents, I believe they're still 00 documents, and they came in as working group documents in the first rev. And the reason for that is it's a split of an existing working group document. Our normal process is we do polls for 00 documents. We didn't because it was a breakup of an original one. The only document that we have as a working group document that's not on the agenda is the security document. There was an update sent to the list, and basically it's waiting to be aligned with the solution documents. It would be unfortunate to publish a document and then have to support a change in the actual solutions that we define and then have to rev it. There's no rush to publish. We can just make sure it goes forward and adequately influences the data plane solution documents. So in terms of our core deliverables, we're making good progress on the first 3. We have working group documents on there for each, and they're working their way through the process. We don't have a Yang model yet. We do have an individual Yang model that's been discussed at the last IETF. It's on the agenda for this IETF. We had some pretty good support for it the last meeting. We're hoping that at the end of this meeting that we'll talk about adoption and the room will feel it's in good shape. But if it's not, obviously we should wait until those issues are addressed. So this is an important discussion that we're going to have today. We have something special going on at IETF 103, and I don't know if Janos, you want to?
Yes. So that November meeting is in a unique situation that we have the IETF 103 first, and after that the IEEE 802 plenary meeting the following week, right after the IETF. And there are multiple activities, of course, are relevant for both groups. There is if you have not known, there is a coordination team between the two SDOs. We meet regularly, and we want to leverage this opportunity to use the weekend in between the two meetings for joint workshops. As for Detnet, we are working on to arrange joint workshop between Detnet and IEEE 802.1 TSN, the time-sensitive networking test group. We had a poll for the dates. It seems that most people are available on Sunday, November the 11th. So that's our target date for the workshop. We are arranging meeting rooms, as it seems at the moment. The IEEE, so Sunday is closer to the IEEE meeting starting on Monday. We had the IEEE meeting last week and have been working with the relevant people on the meeting room. It looks promising that the IEEE can cover the meeting rooms. There will be a registration website to be aware who is coming and prepare badges and so on, as it looks like it will be free. We hope it stays that way. But we need to know who is coming and the badges. More information as soon as we finalize these things and we have firm details confirmed, will be distributed on the list, both in the .NET list and the IEEE email list.
Yeah, this is a really great opportunity for us to better synchronize the efforts that are happening here in the IETF and TSN in 802.1 with TSN, as well as the IEC works. And it's a really nice opportunity to take advantage of. We think that there's approximately 30 to maybe 40 people that expressed interest in it. We had a doodle poll that went out on our list as well as the IEEE list. So we think it'll be a very good information exchange and help both efforts move forward. So stay tuned for the additional information. Oh, and I should say, we really have to thank the IEEE because they're the ones who are going to be providing the space without charge. Well, we expect without charge to any of the participants. And so we really appreciate that. So we're going to move on to the architecture document, and Janos, I think it's actually.
Should I go up there or?
Yeah, whatever you want. You have to just tell me next.
Yes, I know. So as you heard, this is a brief summary on what is happening to the architecture document. If you can go to the next.
It actually works. It wasn't turned on.
Perfect. So we had an initial working group last call, and there have been a number of changes. So we actually have an extended working group last call going on. The initial last call was on 0.5, and the current draft is 0.6, on which the still open last call is going on. As Lou mentioned, it closes this Friday. So in the initial last call, this slide summarizes the main changes. I will not go into the fine-tuned needs. One of the main changes during the initial or due to the initial working group last call is that we have introduced a new QoS parameter, which we call the maximum allowed misordering. So this is the area of in-order delivery, out-of-order delivery. We so far had the loss and the delay related parameters as QoS parameters. This is an additional one. This has been discussed previously and touched upon in other documents like the flow information model, that some applications cannot tolerate at all any kind of out-of-order delivery, but there are some applications that have some certain level of tolerance. And we want to, this attribute, the maximum allowed misordering, is to capture that. This is related to jitter, the delay variation. I mean the out-of-order delivery that causes jitter as well. And so what can cause out-of-order delivery? If one uses restoration techniques, then of course any change can cause in the topology and the update of the forwarding paths. Or if one uses service protection with established, pre-established explicit routes, then the change between the explicit routes can cause out-of-order delivery actually. The tools that we can apply to overcome the out-of-order delivery or mitigate the misordering or reorder packets actually are similar to what we can do with jitter, like we can have a playout buffer that reorders the packets. So I already mentioned service protection. There has been changes in the service protection description as well. Here the idea was to make the description more generic. So in previous versions, the service protection text was very focused on the packet replication and elimination, but this is the architecture document. to give higher layer architectural concepts and not choose technical solution details or not describe the details of the technical solution. So it has been brought a bit higher level, the service protection term itself. Service protection is to address packet loss due to equipment failure or media access failure or memory faults and so on. So there is the congestion protection to address all kinds of queuing and so on type of aspects, and the service protection is for equipment failures. When we apply a service protection technique, we most often distribute the data over multiple parts, typically disjoint or maximally disjoint parts. And as I mentioned before, there are a number of techniques already exist for service protection. For example, the 1+1 linear protection and so on. Depending on the requirements of the Detnet flows or the Detnet service, there are multiple choices, and one can choose which technique is used. On top of the existing techniques, the architecture document describes a high level of a new technique which we call packet replication and elimination. This can be implemented as described in detail by the data plane documents, like the MPLS document, in order to provide the 1+N hitless protection type of service protection. So the architecture documents describe the high-level functions, and the solution details are described in the solution documents, like the MPLS data plane solution. As for the high-level functions of the packet replication and elimination, we distinguish three different functions. The first one is the replication function that replicates packets to be sent along the disjoint paths. On the other side, we have the packet elimination function to keep only one of the copies of the packets of a flow, send it to the destination and eliminate the duplicates. And the third one is the packet ordering function to reorder packets in order to meet the maximum misordering QS parameter I described in the beginning. So these are the abbreviations we use those, and altogether as a collective term we call them pre-off to cover all these functions with an abbreviation. I need to highlight here that the order of the application of these functions within a node is out of scope. That's implementation specific. Every implementation has the freedom to choose which order is applied within a particular node. There has been updates on text related to explicit routes. As I mentioned before, that out-of-order delivery can be a side effect of distributing the flows over multiple paths, and especially if somebody uses restoration, then that can cause out-of-order delivery if any change happens in the topology and the restoration method reacts to it. One of the advantages of applying explicit routes is to provide in-order delivery or decrease the effect of out-of-order delivery, because you have everything planned, all the routes, and out-of-order delivery can only happen when you change from one to the other, and you know exactly how much is the amount or how much reordering has to be applied if it happens. So these were the highlights from the initial last call. Of course, as I said, there were a lot of smaller changes, and due to the significant change, we started another last call to let the working group review the document as a whole and provide further comments. There are two comments or two aspects that we are discussing in the list. There's no document update yet, no revision yet. We are trying to conclude what changes to make, and one of the comments was related to active OEM, that the architecture document should capture that active OEM methods require additional bandwidth. At the first sight, it seems natural or obvious that yes, if you want to have active OEM, then you need to have a bandwidth for that. But it seems that it's good to capture in the document. So this text what you see in the screen is the proposed text. We will most likely add to the corresponding paragraph, and there may be smaller changes in other paragraphs to capture this. And the second one is the sections 4.4 and 4.4.2 and 4.4.3 talk about the control plane, and there's a discussion on the email list to clarify some aspects. So it is just to me it's just clarification and choice of proper acronyms to be used. But we need to distill these two sections. And that was it on the architecture.
We have a couple of minutes for questions, discussion. So one of the things that came up was that there's a acronym called, sorry, it's Control Plane Entity.
Yeah.
And so it was abbreviated CPE, and that's a well-known acronym. Thank you for AD noticing that's a well-known acronym according to the RFC editor, so it's good to avoid that.
Yes.
The proposal I think on the table, and to be clear, I'm the one who proposed it, is rather than change the name, let's just call it CPEnt or CP entity or something like that. But it's not used in a whole lot of places.
Yes.
And rather than get worked up on it. And I think it'd be good to close on that here, or at least get the impression from those in the room, if everyone's okay with CPEnt or whether we should change the name.
Andy Malice, I was actually the one who noticed it first. And it's used in 8 places in the document. So like you said, it's not a lot of places. And I first suggested control plane device.
Right. And the discussion that was on the list is that that implies to many a physical box, while from an architecture standpoint, the control plane can be fully centralized on a box. It can be fully distributed across all the network components. So the device seems a little constrictive.
Yeah, well, I'm okay with entity as well.
Okay, thanks.
Pascal Hubert, I was concerned by the term entity actually because it seems to relate to, but this might be my wrong English, right? But as I read it, it seems to be like a single thing, like again, device prime or a single function. And actually it's a number of functions and they may be distributed. Each function may be distributed, or at least this function may be implemented here and that function may be implemented here. So the term entity for me seems to relate to one thing, like entirety or something, but it might be my wrong English. But any term which would like avoid that confusion with a single stuff would be better than entity.
We could call it a function.
Function, yeah.
Functions then. It's
so CPF, control plane function.
Yes.
Functions, yeah.
Yeah, ultimately, maybe it's good to highlight that we want to capture is, both of you said that the control plane can be fully distributed, can be fully centralized, or can be a hybrid, or the combination of the two, and the architecture is to capture all these possibilities. And we are looking for terms to properly capture it.
Making decisions on the fly is always fun.
Yes.
Should we see if anyone has an opposition to
Norman wants to
control
say
plane function?
something.
Oh, sorry, Norman.
Norman Finn, I like control plane function.
Anyone want to speak up against using control plane function and CPF?
Functions. Pascal wants it to.
An S at the end.
Sure. Okay. It's nice to be able to resolve an issue. So,
Yes.
We'll take it to the list and confirm that.
Okay.
Anything else?
No, that's it. Maybe the next one is me too, I guess.
See if that works.
Okay, thank you. So this is an update on the flow information model. Before going into the details, I need to highlight that that the group has been mainly working on finalizing the architecture and putting the MPLS and the IP data plane solution drafts on the table in a solid number. So, and this was a significant effort of these three documents from the previous IETF to this one. So there has been not much of a progress made to the flow information draft itself yet. What we have done so far is analyze what changes we foresee and what is the work to be done as a consequence of updates in these other documents, the architecture and the two data plane solution documents. So this presentation is just to list the changes we foresee and we have on our to-do list due to the changes on these other documents. As I just explained for the architecture, there is this new attribute, the maximum allowed misordering. In the flow information model, we have this attribute, but it's a binary attribute. So in the current 0.1 version, a flow either does not care, so can tolerate any kind of out-of-order delivery, or have a zero tolerance of misordering. I did not mention that the 0 is a valid value for the maximum allowed misordering. That means that the particular flow cannot tolerate any kind of out-of-order delivery. So the plan here is to expand this attribute to a more refined one to be able to capture this maximum allowed misordering. We have been discussing it with a couple of contributors on how to do it. Actually, theoretically, there are two approaches we can take. We can take the maximum number of packets type of tag to capture this parameter, or we could have a time-related parameter. As I mentioned before, this maximum allowed misordering is related to the jitter, and we have the timing parameters captured in the jitter attributes already. So at least for some of us, the view or the proposal is to capture the maximum allowed misordering as a number of packets, and Pascal has put initial text on the table for this, which I fine-tuned a little bit. So that's what you see on the screen as an initial proposal for this parameter, that the maximum number of misordered packets, for example, a delta of sequence numbers between the highest sequence number that was just received and the lowest sequence numbers that is acceptable. If this the route for the delivery matters, we have sequencing in the packets in any case, and we can use the sequence number information for this parameter. And actually, if it is done by a playout buffer, the playout buffer can use the sequence number for the reordering. Further discussion will be done in the list, and of course you will see the updates in the next draft, which is for comments and discussions. We need further refinements in the attributes. You have seen a discussion on the jitter, for example. I don't have a particular proposal on the table for that yet, but this is coming. Actually, it was pointed out that we should improve the consistency within the draft for the different views we are capturing. So this is a list of the views the flow information model attributes capture. So at the first place, the user has its own view on the parameters like the T-spec or and so on, the flow description. This can be application specific. On the other side, the network provides a service. So for the network, it is the service parameters that is the network view. And we have the interface in between the two, the user network interface with signaling and so on. And these the parameters have to match on the two sides. So we are about to revise this and make necessary changes to make it absolutely consistent. The other thing I mentioned before that we need, when revising the flow information draft, we need to keep in mind to provide a consistency among the other drafts or with the other drafts, like the architecture, the data plane solutions, and we need to care, special care is needed towards the Yang draft, because the Yang draft that provides the data model for the flow information. So that is clearly synchronization between the two drafts is needed. And we will come back to that during the Yang presentation as well. So this is a short update on what is happening in the flow information model. You will see a draft update between this IETF and the next one. Any questions, comments?
Anne Flint from Nokia. What's the relationship of this information model in comparison to ACTN, or is that irrelevant question?
Sorry, I did not hear the second part of the
relationship to ACTN.
ACTN.
Information model for abstraction and control of traffic engineering networks.
So this is for Detnet, and we need to capture the Detnet related service attributes.
Right.
So how to provide an analogy? So if you think of
isn't this also a traffic engineer network? No.
Yes, that's true. So for example, I wanted to. This is what I was thinking of. If you, for example, just taking a look at the topology. The basis could be a traffic engineer topology, but on top we need to know which Detnet functions, like the replication, elimination, and so on, which node is capable to implement of, or things like that. So we need some add-on to a traffic engineer. So, and that's the purpose here as well, that to traffic engineering, there is Detnet service related and flow related attributes that needs to be added.
Okay, good. Thank you.
Thank you.
So also, excuse me, just before you go away. Also, ACTN is very much focused on control architecture. And this, right now, the current document is more focused on the data plane and the data plane implications. And we really haven't had discussions about how Detnet's going to be controlled. And that's something we should start talking about in this working group, but we have to be not get distracted from delivering on our core deliverables. So once we have a Yang document and once we've made good progress on that, we should start having the discussion of what are the control techniques and how does it relate, how would we want to control Detnet in relationship to the existing toolkit, and ACTN certainly fits well.
Okay, cool. Thank you.
I have from Jabber, this is from Greg Mirsky. We may discuss the out of order performance metric with IPPM working group.
Okay, yes. Thank you. Okay, moving on.
All right, we're going to try to have a remote presentation right now. Balazs, if you could enter the room.
Okay, then I should be visible and hearable, hopefully.
We can hear you.
We hear you, but we don't see your presentation.
My understanding was that,
Drive from here.
yeah.
This is number 3. We don't even see you in the queue. It's a little odd. All right, we're not sure if you can see, but we have your first
I
slide
can
up.
see it.
Okay,
That's
so just tell us
excellent.
next when you want to go next.
Okay, so my name is Balázs Varga. Good morning, ladies and gentlemen. And together with Uni, we are the editor of the data plane solution drafts. And if there are any technical difficulties, we might have Stuart also in the room to jump in. So this is about...
Balázs, could you speak up just a little bit? You're a little quiet.
Okay, is that now better?
Yes.
Okay, then let's go to the next slide, which is just showing some history, how this data plane document was done. So previously we had a workgroup document which are dealing both with the IP PSN and the MPLS PSN networks, how to provide Detnet data plane over them. And there were plenty of discussion. We also had some individual drafts which are describing the results of those discussions. And in the last meeting, we have decided that let's split the document in two parts. And let's have dedicated documents to IP and MPLS data plane in order to describe all the details. These drafts are still the initial version, so version 0. They are capturing the major concepts, but there are still work to done. So every contributions are, of course, welcome. And we have to work also a little bit on the language in order to have the RFC 2119 related statements in the documents. So let's look what is inside, and let's jump first and check what is with the IP Detnet data plane. And on the next slide, we have summarized the basics, the basic characteristics and stuff of the IP data plane solution. And this is for IP hosts and routers that provide the Detnet service to IP encapsulated data. We have not created any new encapsulation, so there is no Detnet specific encapsulation. We are using the existing IP header in order to identify flows and provide the Detnet service. So that means that flows will be identified with a 6 tuple. We will have a dedicated slide on that with all the details. And there is a consequence from that, that in the Detnet architecture for the Detnet shim layer, we have 2 sub-layers, the Detnet service layer and the Detnet transport layer. The service layer is there in order to provide service protection and real-time functionality. But that means sequence numbering. And because we have not changed the encapsulation of the flows, no sequence information will be possible to inject it. This is why you can see it with gray. So that means that in the IP data plane solution, the Detnet transport layer, which is providing congestion control related functionalities you can expect. Of course, if you need service protection, you cannot do it end-to-end, but you can do it on a per subnet per link basis using technologies like MPLS or PSN, which will be also highlighted in one of the slides. Next slide, please. The next slide that we are showing are the scenarios which are covered in this data plane solution draft. The first scenario is that we have a Detnet-enabled end system, and it is originating the IP encapsulated traffic, IP encapsulated flow. So these end systems are connected to relay nodes, which will understand the requirement of the Detnet flow, and they will ensure that the resources are allocated along the path for this flow. These relay nodes will Detnet service aware, but they do not perform any service layer functionality. So just again, if you need service protection, you can do it on a per subnet, per link layer level. The next slide showing the next scenario, which is referring, it is not described in detail in the IP data frame document, but it is referring to the MPLS data frame document, because this scenario is when a Detnet IP flow is provided over the MPLS network. So that means practically that the Detnet flow is mapped to one or more pseudo wires and the appropriate MPLS paths. In that case, the end systems are connected to relay nodes, which are mapping the flow to the appropriate pseudo wire and LSPs. And inside the MPLS domain, with the MPLS transport layer, you can provide the tree of functionalities within the domain. And inside the MPLS domain, you might have transit nodes, which are practically simple MPLS label switch routers, making the switching based on the labels, and they might not be able to know at all about that they are providing Detnet flows and what related identification would be needed and so on. But here no details are described in the IP data frame document. We are referring to the MPLS document because that has all the details that should go inside the MPLS domain. Next slide, please.
Balázs, for your information, we can see you now.
Excellent. Okay, the last scenario that is described in the document is when you have a non-Detnet aware IPN system, and it is provided with Detnet service over the IP Detnet domain. In such a case, the end systems are connected to edge nodes, and these edge nodes are located at the boundary of the Detnet domain. And they act as a Detnet service proxies for the end application. And they are initiating and terminating the Detnet service for these non-Detnet aware IP flows. And the flow identification, again, in this case, you can do it based on the existing header information, but we are seeing the next slide. So this slide is showing the 6-tuple, and this is something that is working both for IPv4 and IPv6. And that is practically a traditional 5-tuple where the IP source destination addresses, protocol identifiers, and the protocol source and destination ports can be used. And in addition to that, the DSCP field you can also use in order to identify the flow. So that 6-tuple does not mean that you have to use all this and define in detail. So you can use wildcards, you can use bit masks in order to identify flows. And that would allow also like flow aggregation using such techniques. The next slide is showing the service protection related consideration in this IP data plane document. As it is highlighted here, there is no end-to-end service protection provided. However, here we can see 3 segments in the IP Detnet network. And within the segments, you can use service protection functionalities. But you will not have end-to-end sequencing information. This is why you cannot provide end-to-end free of functionality. Okay, next slide is showing where we need some further discussion and further work. Here we have just listed these topics. On some of them, we already have some text. On some of them, we still have just placeholders in the data plane document. So networks with multiple technology segments, OEM aggregation, this is something for further discussion and to add new text. From the original workgroup document, we have taken 2 chapters related to class of service, quality of service, and time synchronization. We think that this text is something and these topics are something which are candidate for a dedicated document. But we don't want it to delete the text and forget it and start it again when those documents will be created. And now we have fixed the major concept for IP data planes. So some further work and discussion can be started on management and control plane consideration, Detnet IP encapsulation procedures, and how to map IP Detnet flows to PSN networks, IEEE 802.1. At some point, we have the RFC 2119 conformance language, at some point not. So this is something also have to be added and updated in the document. So this is where we are with the IP data plane document. And maybe let's jump to the other new document, the MPLS Detnet data plane document. And the next slide is highlighting the basics of MPLS Detnet data plane. So this is operating and providing Detnet service with both IP and Ethernet layer 2 hosts. And we have also specified the Detnet specific encapsulation. We are just calling it as a Detnet pseudo wire. With this data plane, you can provide both the service, Detnet service layer and the Detnet transport layer functionalities. So service protection reordering is something that is provided, and it is also already documented in the draft. And for the transport layer, it provides the congestion protection stuff, and it is practically supported on the existing MPLS traffic engineering encapsulations and manuals. Let's jump to the next slide, which is just showing some stuff regarding how we have grouped scenarios. So we have two types of end systems which we are distinguishing. Layer 2 end systems. These are where the application, the time-sensitive application, will encapsulate directly over layer 2 its flow. And layer 3 or IPN system where the application is encapsulating in IP, so it is over IP. And these two type of end systems, they require somewhat different service, because for the Detnet layer 2 service, the layer 2 header must be provided between the input and the output of the Detnet domain. So it must be sent also to the receivers as they will receive on the input. For the Detnet routing service, IP over MPLS, in this case, the IP headers are modified during the transport according to the standard router behavior. So you can expect TTR decreasing and so on. The next slide is starting to list the scenarios that we have incorporated in the MPLS data plane document. And the first one is when you have layer 2 end system, PSN end system, which are originating Ethernet encapsulated traffic. And these end systems will connect it to edge nodes, which sit at the boundary of the Detnet domain. And they are responsible for mapping this non-Detnet aware traffic to the Detnet service. And the edge node functionalities are very similar to the EP functionalities of pseudo-wire specification. Inside the MPLS domain, we have the transit nodes, which are normal MPLS label switch routers, and they are generally unaware of the service. And also in case of Detnet, that is the situation. So this is something very similar to the layer 2 VPN service already defined in IETF. Next slide, please. This is showing the Detnet IP over MPLS network, and this is the scenario we are referring from the IP data plane document. So in this case, IP Detnet end system is sending the flow to the MPLS network, and it will be transported over pseudo wires and appropriate, most probably, traffic engineering MPLS paths. So here the relay nodes will map the Detnet flow to the pseudo wire, and the relay nodes will have, during the transport, like SP and TP functionalities from that perspective. And just again, transit nodes inside the network, they are not aware of the Detnet flows one by one, and they are just practically performing switching based on the MPLS loopers, based on the transport loopers. Next slide, please. This is a scenario where the end system are non-Detnet aware. These are IP end systems, and they are connected to edge nodes. And these edge nodes are at the boundary of the Detnet domain, and they are acting as a Detnet service proxy for the end application. And it means that they are initiating and terminating the Detnet service. And the flow identification, in this case, at the edge of the network where the end system is connected, it is based on the existing header information, like in the case of the IP data plane document. And inside the MPLS domain at the relay nodes, the S label can be used in order to identify the flows. Next slide, please. This is showing the encapsulation. As we said, we have a Detnet pseudo-wire encapsulation. It means that you are taking the payload packets and then start to encapsulate first with the Detnet control word. This is the field which is containing sequencing information for the flow. Then we will add the service specific label, the S label, and that will be used by the peer, by the relay node peers in order to identify the flows. And then, of course, below the S label, you can have one or more or zero T labels in order to map the traffic to the appropriate LSP over the network. And then, of course, below the labels, you have to add the necessary data link encapsulation and map to the physical media. So this is hardware encapsulation slide. And let's go to the next slide, which is showing some more details about the Detnet control word. This is something that is new compared to the already existing pseudo wires. It has some special format, but of course it is based on the generic pseudo-wire MPLS control word specification as it is defined in 4385. This control word must always be present, even if you are not using it, because for whatever reason you don't need service protection for a flow. Also in that cases, you have to add this control word. We have defined two sequence number sizes, 16 bits and 28 bits. 16 bits is also defined for TSM, so this will provide compatibility to such IEEE 802.1 network. And the size of the sequence number, this is associated with the S label. And this is something that to be known by the relay nodes in order to have proper interpretation of the sequence number. And one more thing that is new for this control word, that 0 is an ordinary sequence number. It has no special meaning, like in previously defined control verbs in IETF. Next slide, please. Okay, just some words about the flow and payload types. So flows are identified by the S label. S labels are allocated in the platform label space. So here still we have some discussion whether this should be a must or a should statement. Let's do it on the list and have some arguments for the solution. And the S labels must be at the bottom label of the label stack, and they must precede the controller, the Detnet controller. Regarding the payload time, this is something that only the ingress and the egress page node have to know, and practically based on the S label, they can find out what is the situation regarding the time. Next slide, please.
Before we go to the next one, there's a question from Jabber. This is from Yaakov. This is from Yaakov Stein. So the S label is the pseudo-wire label, and the T label is the MPLS label stack. Why revert to old names? I think he got confused. He didn't maybe go back one slide. Maybe it's two slides. Maybe highlight the difference between the Detnet control word and the S label.
Yeah, the Detnet, so for a Detnet flow, you have to have two identifier or two parameter. One is to identify the flow, and this is what is encoded in the S label. So this is how you know which flow we are speaking about. And the Detnet control word is containing the sequence number information. And we always must add sequence numbering information. This is essential to being able to do replication, elimination, and in-order delivery.
I think so Yaakov is saying, I understand what a control word is. This is precisely the pseudo-wire stack. I think the pseudo-wire is in normal pseudo-wire label would be the Detnet control word. The S label would be a context MPLS label. It's not a pseudo-wire label, but it's a context MPLS label. And I think that's the point that the question's on.
Okay.
Although Greg Mursky just typed in no. S label in pseudo-wire in PW3 terminology is a PW label. And then Yaakov is responding. We're having a little bit of an argument in Jabber. That's great. Yaakov is responding. No, the CW is not a label. And Greg responds that the pseudo-wire control word is a Detnet control word.
Stuart, Brian, I think we're sort of getting hung up on names and we should focus on the functionality. We can sort the names out at another time if we want. There are some sort of differences between the way pseudo-wires work and the way Detnet works, I believe, in terms of the added functionality of Detnet. I'm fine with them being called something else. If the consensus is to move them and merge the names, I'm also fine with that. But I think this is a perfectly fine set of names.
Yeah, I think we wanted to highlight the differences to the existing stuff. This is why we have this name. But I agree with Stuart's comment regarding on naming. We can have some further discussion. Okay, maybe let's continue. Yeah, there are also some stuff again, also in this draft where we need some further work. We have some very good initial text on flow aggregation. This is this is there in order to initiate some further discussions. We feel that it is very important to high flow aggregation because that will provide the possibility to improve the scalability of the data plane solution. And here, Stuart have already documented 3 methods for flow aggregation. One is where we are aggregating at the LSP level, so practically the transport, Detnet transport layer. We can also make aggregation of Detnet flows with creating a new Detnet flow, which is the aggregate flow. And we can have also aggregation at the Detnet layer. So these are particularly the 3 methods which are described. Some further discussion and working on the details is something we plan for future versions of the draft. And on the next slide, we have also summarized. Oh yeah, first the pre-op related stuff. So as you have heard also during the architecture draft presentation, we have now concluded to have the abbreviation used for this application, elimination, and ordering function. And this is something that is also described in the MPLS data plane document for the H node and for the relay nodes, how these functionalities are working and what those nodes have to fulfill and have to provide in order to make this service protection correctly. Now on the next slide, we will already have a special scenario where it is MPLS over IP Detnet PSN. So that means a Detnet server wire to forward over IP Detnet PSN network. And that means practically that MPLS over UDP and IP encapsulation. And here in the figure, you can see the resulting encapsulation. So you can have the Detnet control word and the S label, and then you may or may not have T labels. This is why it is gray. And then the rest is encapsulated in UDP and IP. And then you will be able to transport such a Detnet pseudo wire over the IP PSN network. Next slide, please. This is just summarizing some further work where we have already work in progress. So class of service, quality of service, cross-Detnet flow resource aggregation, layer 2 addressing, and quality of service. Here we have also copy-paste the time synchronization related stuff. As already mentioned, this is something the candidate for the publication document. And on the next slide, we have also highlighted as the basics of the MPLS data plane are now documented, and we feel that we have a consensus in the work group on that. That on management and control plane related stuff can be further discussed. How to make interconnection of PSN domain over a Detnet MPLS service, and how Detnet MPLS transport link operation over a PSN subnetwork can be provided. And just again, as with the IP data plane document, so a conformance language is still to be updated and to be added at some point in the document. And practically that's currently. So as said, these are version 0 documents, just documenting where we are currently, and any comments, questions?
Yaakov Stein has one from Jabber. His comment is if we call it a Detnet pseudowire, then it should use pseudowire terminology and use pseudowire control word. It's almost there. I think there was a discussion among the authors about whether or not to use pseudo-wire terminology or not. And actually, we had it in several times even in the working group. And I think we decided that we would avoid the term pseudo-wire because we didn't want to constrain the way that the control word and the Detnet services are managed. For example, that they could be managed using EVPN approaches, which has a control word but is not a pseudo-wire from some people's perspective. Other people's perspective is exactly a pseudo-wire. But I don't know if the authors want to make a comment on that. But I think that's the answer to Yakov's.
I hope to have the document as an RFC, and maybe then this discussion will end. Assuming is that can be a very long story to discuss on naming.
Yes, Stuart, I think it kind of depended on whether you started at the architecture and worked your way down and carried the architecture specification and naming down, or whether you kind of jumped to the bottom and said, in one particular case, because remember it is only one particular case, we're going to do this with a pseudo-wire construct and we should use pseudo-wire terminology. So depending on whether you started from the top or the bottom, you ended up with a different terminology. We've chosen to start at the top and propagate in this particular document, propagate the terminology down, I believe. It's a perfectly fine way of describing it. I have no particular hang up over whether which of the terminologies we use, but we kind of decided to stick with the architecture one and propagate it down.
Andy Malice, I'd just like to point out that while this is not the preferred control word, it does conform to RC 4385, which defines the PV3 control word.
Yes.
Yeah.
Okay, so two more things from Jabber. First, Yakov says that he sent mail to the list, so we'll continue the discussion there. That's great use of the list. And then Greg Mirsky has two comments. The first one is he has some comments on NCAP related to OAM, but he has a presentation on that. So he will talk about those specific comments there. He also says use of the DCW has some consequences on OAM. And this brings up a question. I'm going to ask it now while we have Balazs in the room, so to speak, and then we'll ask it again when Greg's presenting his OAM draft. Is where do we think the OAM related to the MPLS control plane, MPLS data plane belongs? Does it belong in the data plane document or does it belong in a separate OAM document? And I think Greg's bringing up a good point about that you might have some implications on the definition of the encapsulation if you don't take into account OAM.
So Stuart, Brian, I'm not sure I understand Greg's point. The design is consistent with the most basic version of the pseudo-wire control word, and if the OAM is done with using the ACH mechanism, it is still consistent with that. There's just you set the 4 zeros to 3 zeros and 1. So I'd like to understand Greg's.
He has a presentation on that, so why don't we defer that part to his presentation. Do you have any comment on whether or not you think the OAM definition belongs in the MPLS data plane solution document, or does it belong in a companion document?
I would put it in a companion document, making sure that the data plane document has got enough hooks in it that you can do the OAM indicator on it. So clearly we should make sure that it's possible to specify how you know it is OAM and the characteristics of the OAM following the same path, etc., etc. But the detailed OAM design is going to be a big piece of work in its own right and really belongs in its own document.
Okay, great. Both Greg and Yakov have typed into Jabber that they like companion as well. Any other comment from the authors on that, Balazs?
No, that's fine.
I'm going back to see if I missed. I'm sorry, go on.
No.
I missed one comment that came through on Jabber a little bit ago, so this is a little taken out of order. My apologies. Jakob Stein writes, Andy, it does not conform. The Ethernet's control word avoids the 0 value, and the TDM control word has a shorter SN. So I think it's.
I'm not sure I agree with Stuart. I'm not sure I agree with Yakov. I mean, the particular control word design with the 0 indicator only applied to a certain class of pseudowires. You can have whatever design you want. The only piece that's important in the most basic design is that you have the first nibble set. So it sounds like we need a longer discussion perhaps on the list.
Yeah, that would be great. Thank you. And if appropriate, I know you're the PALS chair, so you'll think of it, but if appropriate, we can include the PALS working group in the discussion as well. Great, thank you. So both the documents that were just presented, the IP solution and the MPLS solution, they have a lot of good text that's basically defines what the path is for the working group. It reflects what's been discussed in the past. It captures each of the details separately. It doesn't have all the conformance requirements yet, but it has all the sort of narrative to understand what the solution is. Now would be a great time for those who have not yet read the document or haven't read the solution data plane solution document recently. It'd be a great time to go read it, make sure that it's clear as to how the data plane is supposed to operate, and two, make sure you agree, because what's going to happen now is to move on to basically getting all the details that while it's really the meat of a proposed standard to have all the conformance statements, the fundamental pieces, those fundamental definitions are just going to relate back to the text that's already there. So now's a really good time to read the document and provide comments if you haven't read it recently. Blanche, anything else?
That was an excellent close for the data plane document.
All right, thank you very much. Norm, I think you're up next.
Yes, Norm, you are the next one.
All right.
Starts over there. Anyone who has not signed the blue sheet?
Let me know. Okay. Hi, I'm Norm Finn, one of the authors of the bounded latency draft. I'm not going to talk about the whole draft. I'm going to talk mainly about the new work, the new stuff that's been introduced by Jean-Yves Le Boudec and Ehsan Mohamedpour of the École Polytechnique in Lausanne. We had a presentation from Jean-Yves about his network calculus, and this is critical for the aspect of Detnet, which is the upper bound to latency and the zero congestion loss. A reminder to the new folks, we're interested in bounded latency, not low average latency. Low average latency is nice, but bounded latency is critical to real-time applications. Feedback that slows down the source is not an option in this space. And we need mathematically sound assurances on latency and congestion loss. Now, I'm going to skip ahead a couple of slides. There is a standard in progress in IEEE 802.1 called asynchronous traffic shaping, ATS. And what this talks about is a second layer of queues. Now this is perfectly compatible and a natural thing that we've done for years in terms of per flow queues. It's easy, we've known in serve days in the 90s that per flow queues can give good QoS. What's novel about these queues is that you can share any number of flows on one queue as long as those flows come in the same port and go out the same port. If you have a number of flows that come in on one port and go out on one port, share the same route through the router, bridge, whatever, then you can put all of those flows in one queue. You still need a separate shaper per flow, but as the packets come to the front of the queue, you can say which flow is this and apply the correct shaper, and you get by with fewer queues in the box. That's not necessary, but it's an optimization offered by this. Now, what does this have to do with Detnet? We, in Jean-Luc's and Ehsan's papers, they call the extra layer of queues, the per flow queues, an interleaved regulator. The interleaving being multiple flows sharing the queue with separate shapers. The key is the second point here. Adding the interleaved regulator means that your computation of end-to-end latency for a flow is linear with the number of hops in the flow. In general, if you're trying to figure out what is the latency of this flow to the through the network, you have to analyze the impact that every other flow that crosses its path has on the flow you're analyzing. And to see what that impact is, you have to analyze the impact of other flows on the flow that affects the flow you're trying to compute. Okay? It's an exponential problem in general to compute the worst case latency of a flow through the network. If you add this interleaved regulator at every hop, then you can treat the interference from the other flows as an aggregate. And the calculation becomes, the complexity of the calculation becomes linearly with the number of hops. And that's a huge difference for making the network practical to use and making it practical to make reservations. The new work that's in the papers that are at the reference at the end of this, and the definitions, we'll get to how right here, to how this is important. You have the queues here are the queues that you normally have at the output port. The regulator is the additional per flow queues. The critical point that he makes is in this green box there, which is that if you look at the total end-to-end latency, the regulators, which are adding delay, metering the data out before they get to the per port queues, add nothing to the end-to-end delay. The reason for this is that if the regulator would slow things up, the only reason the regulator slows things up is that something has moved quicker than normal in the previous hop and filled it up. And because it moved quicker in the previous hop, there's no penalty to slowing it down at this hop. There's a slide coming up that'll make this a little more clear. First of all, I want to show how the regulators work. The idea is that flows that come in from the same port in the left hops are combined at the output queues. You have the flow regulators, one flow regulator per input port. That would be the red and the green, two different input ports, go through two different regulators. They then come out as the yellow stream. When it gets to the next hop, the stuff that goes to one port goes in the green path, the stuff that goes to the other port takes the red path. And again, the inputs are combined. Everything from one port goes through one regulator, and the regulators are combined. This shows how this works at every hop. When you compute the total at every hop, what you when you're computing the total delay, you add up the delay at each hop, of course. The trick is that if you compute the worst case delay for every hop and simply add them together, you get a very pessimistic estimate of what the total end-to-end delay is. The reason is the worst case delay at one hop can only occur if you've drained stuff from previous hops and filled up the queue at this hop. But if you've drained stuff from previous hops, that meant it moved faster through the previous hop. You can't possibly have the worst case at every hop. And when you compute what the worst case is, that's where you come back to this slide, which says that essentially the regulators are free. So the regulators enable the computation to be linear and cost you nothing in end-to-end worst case delay. This is an extremely valuable property. Now you can look at this as int-serve works, and yes, that's true. If you want to look at the new asynchronous traffic shaping document, it shows how you can implement int-serve with something less than a queue per flow, which is nice. Here are the pointers to the papers that make this clear. I will mention one other thing that's going on. There is a new project has been approved for 802.1 TSN, which is a document entitled Quality of Service Provision by Network Systems. I quoted the scope here, which is the contract with IEEE Standards Association for what the document is supposed to do. And the point is to offer a document that allows a device which is not a bridge to obtain all of the quality of service features that we have defined in TSN for bridges. If you've seen 802.1q, it's now, I believe, over 2,000 pages, and it's all about how to build a bridge. Most of that is irrelevant to someone who's not doing a bridge, for instance, doing a router or a label switch. 802.1 DC will explain that if you're building a network relay device, and I don't care what address family you're working on to forward your packets, I don't care whether it's a router or a label switch or a NAT box or a firewall or anything else, if packets are coming in some ports and going out other ports, here's what to look at in 802.1q to tell you how to build a device that can claim I conform to the QoS provisions of 802.1q. I implement the queuing mechanisms defined in 802.1q so that I can get the TSN class of services with my box, which is not a bridge. That's what the purpose of this document will be. I hope that it would be a reference from some of the RFCs that we do. Any questions?
Pascal Hubert? Quick question on your regulators. I mean, it seems to me that it works as long as all the flows that go out to SMQ are all regulated, right?
Say it again.
The way you presented the regulators, I understand that it works as long as all the flows that go out the SMQ are all regulated, right? You can't inject traffic which is not.
Yes, all of the flows sharing a particular low-level queue must be regulated. Yes, so you reserve certain low-level queues for regulated flows, and you have other low-level queues for best effort traffic.
Thomas Eckert. So this is cool. I think that obviously, there's a little bit more about what happens in larger routers internally in terms of, expectation of having a blocking-free fabric, for example, so that anything from input port R to output port B does never, get unpredictable.
There's no assumption of non-blocking. There is certainly an assumption that you have the ability to refuse a reservation.
No, I think it's basically the point that you need to figure out what's the worst impact of other traffic going through the router that is basically delaying your A to B port. You
only have to worry about the reserved, the Detnet traffic for which you have a reserved bandwidth.
Right, but again, you have a fabric. Other traffic may impact your A to B traffic as far as the incurred delay within the box is concerned.
Other traffic may delay.
You're looking at an A to B pair, right? A input, B output.
Yes.
And basically, we'll still need to be able to figure out the worst case delay within the node based on, other traffic that is sharing the fabric within the router.
Yes.
Right, so.
But it's subject to the same analysis.
It's subject to the same analysis. All I'm saying is that the problem is a little bit that a lot of the TSN stuff is based on a lot simpler node designs where, a lot of the internal complexity that we have in larger router isn't in there. So we'll need to be careful.
The model includes variable delay from other traffic, okay? If your box has a design such that it's not deterministic and the Detnet flows don't get suitable priority, then no, you can make no guarantees, of course.
The more important question I have is, this was called a requirements document, but this cool stuff here is more like one of the possible solutions. So would it be fair to have that really also be in a separate document?
Don't get too confused.
I'm sorry, I didn't hear the end of the question.
Sorry, I apologize.
Can you just finish the
Yes.
Yeah. So I think this stuff to me looks more like a cool solution, not as a requirement, right? So would it be fair to basically put this into a separate document?
There are two documents on the table. One is bounded latency, the other is bounded latency requirements. This is not bounded latency requirements.
Okay, good. Thanks.
Yeah.
That does bring up a point I wanted to raise at the end, is right now you have this listed as a proposed standard, which means it's a required implementation. Did you mean that?
When I put it up, I did.
Yeah.
But going forward, I've heard the suggestion that it would be better as informational, and I'm certainly willing to talk about that and see what's the best
I think
way
that makes
forward.
sense. I mean, certainly the service a box delivers is something that's going to be required by Detnet, but how it does it is it's an implementation choice. And we usually don't specify that.
Understood.
So informational sounds right.
And we need to have that discussion. Yes,
Well,
I'm not in principle adverse to that. So
do you still want to pursue making it proposed standard? Or are you just going to shift to?
I want to discuss it on the list, and I need to understand why it wouldn't be. I think I'm learning, and I'm not dead set that it needs to be a standard.
Okay. Just
so you should hear my arguments, and I should hear your arguments, and either way it works out is fine.
A quick just poll feeling from the room. How many people would be interested in defining a document that prescribes queuing behavior of a implementation? So either no one understood the question. Oh, I do see one hand, so at least someone understood the question.
Can I make some observation about, this in general?
You don't want me to finish the second question?
It
Can I
is
ask
an
my-
observation about the question, not
Sure,
a
go
pure
ahead,
answer.
please.
So I think,
Name, please.
Thomas Eckert again. So I think there is a difference with respect how the IETF treats this stuff, whether or not there is something observable between the notes. Right, so the way I understand it is that this proposal solution from Norm can actually be something internal behavior and does not introduce anything new on the wire. Other queuing solution might. So you were asking about standards versus
Let me finish my
non-standards.
questions. I want to ask the room two questions and then we can continue the discussion. So the first question is, how many people are in the room are interested in prescribing an implementation, a specific implementation inside a piece of equipment? Please show of hands. So I would say that's very few. How many are interested in, or think it's useful to have an informational document that represents one possible implementation of a device that would support Detnet services? So that's
Somewhat more.
It's definitely more.
It's at least twice
I
as
wouldn't
many.
call it like half the room, though. So it
No,
wasn't
no.
a lot.
But it's
How
more.
many are not interested in this topic at all? This is based on those last two. And we have no one. So that's an interesting thing. So we have two people in queue. We have 1, 2, and then 3.
So the problem is that I think, if we all want the requirements document for the bounded latency, right, to be a core of the working group, then, not having an opinion about how to do it is basically escaping to answer, right? So that's, no, I mean, the problem is that customers who want to do a DevNet or so, right, really need some guidance, right? So you're putting cool requirements in there and saying DevNet can be done, and then we're kind of hand-waving how to do it, right? So I think we need to be a lot more stronger if we hopefully all agree that the bounded latency is at the core of what we want to achieve, so.
So just to be clear, you're arguing you would like a standard queuing implementation.
I don't even think we need to have one standard, right? I think we have such a broad range of requirements and networks from large to small scale, right? So that I'm not sure that one solution will fit all, but definitely we need to do more than just requirements. And informational, I think, is the minimum that we can do for any solutions. That's my opinion.
Okay. And we also have in queue number 4, a couple of jabber. So two.
Paul Congdon, Telak Networks. So
I'm sorry, what was your name?
Paul Congdon.
Thank you.
Telak Networks. You asked a question about a queuing specification. Personally, I'd be in favor of a queuing specification in 802.1, in particular the DC document, and I'd like to see an informational document that references that.
Okay, thank you.
Two questions, two technical questions. The first one is about the accuracy about, I'm Bing Yang from Huawei, sorry.
Oh, thank you.
Okay. The accuracy of the scheduling, so the key point of this technique is about the interleaving between the packets, right? So the time-controlled scheduling is the key point. Whether it is accurate or not determines whether you will miss your deadline or miss your time to schedule. So I'm asking if there is any analysis on the accuracy, because routers and switches are not always accurate.
Right. The techniques that we've talked about in 802 and the stuff that Libodek and Mohammedpur have presented have treat inaccuracies like that as uncertainties in forwarding delay, uncertainties in queuing delay, and those uncertainties are factored into the computation of the worst case latency. So that the number you get from the computation is slightly pessimistic, assuming worst case inaccuracies, according to the implementer says this is my worst case inaccuracy.
Okay, I didn't see that in the paper, but I will check it later. The second question is about the multiplexing. You know, you have to support the Detnet flows with the together with the best effort traffic. But if you want to reuse the resource of the interface, you may, after you send a Detnet packet, you have to send another best effort packet. In that case, but you have to control the interleaving between the Detnet packets. So if you have, my question is that if you have best effort packets between your Detnet packets, so it may, there are maybe two cases. One is that if you do not want to miss the earliest deadline of the Detnet packet, you cannot use the resource.
At every hop, there is if you have no Detnet packets that are scheduled to be transmitted at this instant, if all the Detnet packets are being held up for regulation or for bandwidth limitation on the lower queues, if none of the Detnet packets can be transmitted at this moment, then yes, you transmit a best effort packet. And if 1 femtosecond after you start transmitting the best effort packet, a Detnet packet becomes eligible, then there are two possibilities. One is you wait till the end of the packet to transmit, and that interference is included in the calculation for worst case latency. The other possibility is that you preempt the transmission of the best effort packet after a few tens of bytes and transmit the height, in which case you still have interference, but the interference is smaller. If you've just finished transmitting a Detnet packet, and there is another Detnet packet that is ready for transmission, then you don't interleave with a best effort packet, you do the next Detnet packet. There's no requirement that you interleave Detnet with each one. If you're using time scheduled, and we talk about reusing unused reserved bandwidth, if you're doing time scheduling, for example, you can enable both Detnet and best effort during the same window, and you give the Detnet higher priority. So if you have Detnet traffic, it goes. If you have no Detnet traffic, then the best effort can go. So either way, that's factored in.
I understand the theory, but I mean, if the time between the two Detnet packets is too short to schedule the best effort packet,
yes,
then the resource will be wasted. So I mean,
no, the resources, it depends. If the interval between the two Detnet packets is smaller than the minimum size of a preemption fragment, then that's true. But the biggest reason for preemption is, for those who are unfamiliar, preemption is an new 802.3 standard that allows you to interrupt the transmission of a low priority packet, transmit a high priority packet or 5 priority packets, and then resume transmission of the interrupted packet. The biggest reason for that is so that you can fit best effort traffic between the in the intervals between Detnet packets when that's smaller than a full packet. So that way you don't waste so much bandwidth.
Maybe this can be continued in an offline discussion.
Yes.
Like
Okay,
these
thank you.
details.
Thank you very much.
Great to have the details discussed on the list as well. Before we go to the last question, we had a couple of comments from both Greg Mirsky and Yakov Stein. The essence is really 2 points. The first is Yakov is saying if it's that an informational implementation document would be very useful.
Yeah.
So, but informational.
Yeah.
And Greg agreed. The other comment, it was actually earlier from Greg that basically was saying is if it's standard, there's actually another working group that standardized queuing techniques. And if you really want to standardize it, perhaps think about going there. And that's the AQM working group.
Okay, good.
Adaptive queue management. Their focus is a little different, but they do standardize queuing techniques.
Yes, I think it would be, the way I'm leaning right now is that we need an RFC here that's standard track that says, this is what's required of any low-level. These are the characteristics that are required of any queuing mechanism in order to meet our goals. And perhaps an informational RFC that says, by the way, here are some techniques that meet the goals.
Right, that would be informational.
Exactly.
Per our process, that would be
Yes,
informational.
I think that's where I'm leaning now.
Okay.
Yes.
So we're 5 minutes over. We'll steal it from later, but if we can be 2 quick questions.
Okay, very quick question.
Name, please.
Xue Song from Huawei. I'm just very curious about whether, because the bounded latency is from the requirement of the transport layer of the Detnet, right? I'm just curious whether different mechanisms of the queuing will influence the encapsulation defined in the data plan.
To my knowledge, the encapsulation doesn't affect which queuing mechanism you use.
For example, in the slides you just introduced, the per flow queue maybe require the flow identification for the transport layer. So
yes.
It's different, right?
Yes, you can't do per flow queues unless you can identify the flow.
Yes. So I think, yeah, the influence more, perhaps the influence.
Thank you. Then I would take that as a correction to what I said. You are right. It must be possible to identify the flow. Yeah. And in that sense, the assumption of the documents so far of .1 and so on is that you have a choice between deep packet inspection sometimes in the middle of the thing. And
Norm, we're really out of time.
Out of time.
Please take a look at the solution documents and see if it has sufficient description for how to do flow identification, at least within the unaggregated case. You saw in the next steps, in both documents, they talked about the need to do more on aggregation. So at least in the unaggregated individual flow identification case, it should be covered. Please take a look and make sure it's sufficient.
Okay, thank you.
If the next presenter can come up, and while they're coming up, if you want to ask your question. And Norm, thank you very much.
I'm sorry for going over time. I think we had a lot more questions than I thought.
Good talk, but I'm kicking Norm off this stage, so because we do have other. The next presenter is actually remote, right?
Yes, yeah, I think remote.
Is Liang Deng. Oh, great, thank you.
Great, thank you. So this is Liang from China Mobile. I'm sorry if this title has introduced some confusions. This is really not a general requirement on bounded latency. This is a more specific requirement of bounded latency in large-scale deployment containing a service. So basically, this is really a brief introduction of the requirement. And following my presentation, there will be another solution-based presentation which talks about more detailed solutions to these requirements listed in this document. So some background, in Detnet, we have really well-defined architecture and the service. And also we have MPLS and IP encapsulation method, which of course deal with the Detnet service encapsulation. And also the service protection, which is actually another way of understanding deterministic in packet loss. So it's not deterministic latency, but it's deterministic in terms of packet loss. And we also have solution paper on security requirements. But to my knowledge, there is yet a solution, a native, a Detnet forwarding plane solution for deterministic latency. We rely on TSN solution for end-to-end bounded latency. But remember that TSN is designed for local area network applications. Is it good enough for large scale? This is really where these requirements coming from. Next slide. So here is actually the first requirement, what I call it stitching different TSN domains with bounded latency. So if we assume that we have several TSN domains that interconnect, we basically have two options. One is to basically have a, for example, a greenfield implementation of end-to-end TSN-enabled network with strong time time synchronization end-to-end as well. This, of course, provides by using TSN methodology bounded latency end-to-end. Option 2 is to regard the system as TSN1, then Detnet, and then TSN2. These two domains of TSN are not actually synchronized. Then you will have to have a Detnet connection between these two domains, which provide natively the capability of maintaining the jitter performance between these two TSN domains. We assume that there's no TSN aware equipment in between. So this is requirement 1. Next slide, please. We know that in QBB, for example, when you have a new TSN flow injected into the network, the centralized controller will have to recalculate basically the table of the gate control list to give you a update of all system flow with the new status of bounded latency performance. But what we have observed in terms of Detnet service, we talk about, for example, virtual reality, aggregated reality, or even holographic communication type of things. It's really the consumer and the generator of the traffic may locate very deferred locations. So we expect that it might not be one-to-one or one point-to-point service. It's also one to multi-point or multi-point to multi-point services. We expect the service to be established or tear down much frequently than the scenario in a local area network. So is it feasible to have a QBV type of methodology to calculate every time when a new flow is injected to the network? Or do we have a mechanism where the convergence can be more faster instead of scale with the frequency of a new services establishment? And the third requirement is, can we have a certain level of tolerance of end-to-end time deviation? That is also because time synchronization, although, for example, in China Mobile, we have a synchronized backhaul network because in 4G, we're basically in a TDM technology. However, it is very costly. You need to have the equipment to be end-to-end supported. Either it is, for example, Ethernet type of synchronization technology. And it's very hard if we have a service, end-to-end service that go over a heterogeneous network. You basically are out of control of the network, whether it is capable of transmit the time synchronization signal. So is there a possibility that we have an unsynchronized environment, an unsynchronized network, which can also provide bounded latency with a comparable performance as TSN network? So this is the third requirement in last year. Next slide. Yes, the fourth one is, given the variety of Detnet services, we will expect that the resource reservation status will be in a big number of effort as well. So is there any mechanism that we can aggregate to some extent at some point of a Detnet node to basically reduce status we need to maintain for resource reservation? Of course, there are trade-offs because aggregated emits some information about the finer granularity of the resource reservation. So there will be some study to be made in this field. And the last one, in 802.1qch, it is required that the data packet transmitting from node A to B to have a transmission delay that is much smaller than the cycling of the cycling queuing forwarding period. So this is required by TSN method in QCH, which means if we do the calculation, jitter performance is actually scales with the cycling period, which means if you have a really very long transmission delay, you will be obliged to increase capital T to basically fit with this requirement in QCH. So if we have a very long link or very delayed link because of your transmission media, these basically jeopardize your jitter performance as well. Can we find something that can get rid of this connection between your delta T and your cycling period? This is the tolerance of transmission latency requirement, which is the last requirement in this document as well. And next slide, please. I think it's the conclusion. So there's yet a native Detnet layer solution for deterministic latency transmission. We're not saying that we can't deal with deterministic latency. TSN is a great solution, but when we think about large scale, there might be some problem. And the solution could be based on QCH, but it has to be scalable about the cycling period type of requirement. And time synchronization, yes, we see some synchronized network in large scale in nowadays, but it costs money. If we can achieve similar performance or comparable performance with the TSN without requiring time synchronization, then it will be preferred large scale deployment. Thank you. That's basically
just two comments for completeness. That TSN overlay is one of the cases, but TSN is as well considered as a subnet possibility to be used to meet the requirements. So it is illustrated in a number of figures in the architecture document. And another thing is that there is asynchronous solution for TSN as well, as in the previous presentation pointed out. The asynchronous traffic shaper does not require time synchronization. I should suggest to move on to the next presentation because the two are together, this one and the next one, and have questions and comments after the next presentation.
Thank you very much. The remote presentation worked well.
Thank you.
So we're going out of order. Just as a reminder, we're taking what was originally labeled 10. Not sure who's presenting that. Is it Christina? Torlis? You. So if you can present in 5 to 8 minutes, so we have a couple of minutes.
I'm always getting that special treat from you.
Yeah, so if you then, so we can leave some time for questions. Sure. Because it's important to leave.
Right. So, oh, okay, that's my screen. Okay, so this is a proposal solution for the requirements that were just presented. And so the goals are really to have a solution with really what we call tightly bounded delay where really the range of arrival time of individual packets can be defined to be bounded within a really small delta between a minimum and a maximum delay. The delay itself, of course, can be large through a network, right? So in the typical edge network, we may be talking about really milliseconds, something which is, completely orders of magnitudes more than in typical TSN deployments, because we're talking about wide area and not within building. But really, most of that is going to be the speed of light through the propagation delay. So what we've put in here is something that can become a framework for control plane and forwarding plane, but we've really only detailed so far the forwarding plane in any sort of detail. But I think we all know that there are control plane requirements that come out of the forwarding plane that we're building. So the scheme that we're proposing to use is based on the ideas that are coming from TSN, but adopted really for these layer 3 networks with much longer delay on links, much larger routers, so with hopefully much less constrained requirements against network-wide tight clock synchronization, and then the ability to support all this variability in the forwarding, whether it is higher bounds of forwarding within the node or higher bounds of forwarding on the links. So here's kind of the overview picture of how this looks like in the network. So we've got our senders and we've got per flow state to basically do the equivalent of what they're calling in TSN the gate functionality to schedule and shape out the packets. But then across the core of the network, we only have aggregated state and not per flow state. And that is really the core piece of creating scalability for potentially millions of flow through a big service provider network that wants to provide deterministic services. Next slide. Oh, that's me. Okay, so here's basically a quick comparison of what we call our large-scale deterministic network scalable deterministic forwarding data plane. So it is sharing the cyclic forwarding insofar as that we have a bunch of queues. We think that we get away in the best cases with 3 queues that are being cyclically scheduled on output. And when we're receiving packets on input, we know basically what queue they're for and we're mapping it into. And so if you look on the left-hand side, that's the TSN solution, and that's where really these slots are tightly synchronized between input and output, so the propagation delay of links between these nodes can only be a small portion of the actual cycle time, whereas in our solution, the propagation delay of the links can be arbitrarily large because we're basically doing explicit mapping. So something is being sent from a cycle X, and we're actually including the cycle as information in the packets, as we're seeing in the next slide. And that is basically being mapped to then cycle Y that is sent, so to speak, as soon as possible after having received all the packets for it, right? And so that basically means that hop by hop, we're not incurring any additional jitter, we're just incurring additional delay. Right, so this does it in more detail, showing the cycle mapping. So given the limits on time that were given, I'll leave that up for reading. This, I think, is the best representation of the overall process. So you're seeing up node A that is sending packets, indicating the cycles that they're sending from through a label. We're thinking that we can get away with 2 bits in the whatever headers we're having in the network, right? And on the right-hand side, we're seeing a small set of possible encapsulations where we can put these 2 bits to just indicate 3 values for the cycle. So takes arbitrary amount of time to get to node B. Node B sees it, picks up the label, and then basically through the mapping puts it out into the appropriate cycle and then sends it out again. Next slide. Oh, me again? Okay.
Either one of us.
Yeah, either. Right. So yeah, so this is basically really the more cooler, interesting parts where we think we're kind of 50% through defining the solution. The first one, of course, is what amount of synchronization do I need between the device? And I think that's true whether we're using the cyclic queuing or any other solution, right? If you basically start creating packets 20 or 30% faster because your clock is running 20 or 30% faster, you won't have a solution working. So there is a certain amount of frequency synchronization required between any set of devices through which packets for a deterministic network are going to run. And in our case, what we can do is we could basically deal with larger derivations between the frequency synchronization. So one clock runs a few percent faster than the other through basically increasing the number of cycles that we're basically pushing packets up front. And that basically would then allow to correct for frequency synchronization mismatch. The more interesting stuff probably is that we're going to have link delay variations. So I'm not sure about all the cases in networks, but you know, we've got these wonderful hanging wires on poles that are going to be longer and shorter over the period of 24 hours. And that can be as much as 10% change in propagation delay. And so that's basically also something very easily managed by this solution. You just need to basically do some calculation of, you know, measurement, long-term in-band of the change in the propagation delay, and then adopt appropriately the mapping so that you can still receive all the packets and send them out without any variation in delay. So I'll skip the control plane, and yeah, that was basically it. 5 minutes, so summary here again, right? No per flow state in the core of the network using the principles that we know from TSN solutions, adding label field with just the number of bits required to represent cycles, and then having on the edge, on the sender side specifically, as necessary, the same type of gating state as we know from TSN.
Yeah, Norman Finn. Thanks, Curtis. As far as the two buffers versus, there's several aspects of this, okay? I think there's a certain amount of characterizing .1QCH, the cyclic queuing and forwarding thing instead. In a very narrow sense, it's better than that. You're absolutely right about 2 buffers versus 3 buffers. I'll send the pointer to the list. We pointed that this has been discussed. The first one I have is 2014, presented exactly that idea, and you're absolutely right, and that is allowed in QCH. That is supported in QCH to do 3 buffers.
I was even thinking that some of the stuff that you had in 2008 and 9 with explicit labeling in the forwarding plane also refers to this.
Exactly. So, the trick is, as you've identified, is identifying to which cycle an incoming packet belongs. Because it has to stick to the right cycle.
Right.
Okay.
Well, it's even.
I agree.
So we're getting to a level of detail. We actually should take it to the
We'll
list.
talk more then. That's great. Get down in detail.
No, it's good stuff. Unfortunately, we just have too many other agenda items.
And maybe the key part, and that's why I was bringing up standardization versus informational, right, is whenever we do something different on the wire, then we have the question of how we best basically get that formalized.
So we were talking about this offline, and I think our read of this is where you're aiming is to describe the queuing mechanisms you'll need once we have an aggregation mechanism. So once we have marking that allows aggregation of flows, we need some queuing discussion related to dealing with those aggregated flows. And it seems like that's really where this work is headed.
True, but I think you can come up with any type of aggregation mechanisms. For example, Norm's mechanism that he presented has an in-node aggregation that isn't visible on the wire.
This is independent of aggregation, Norm Finnegan. This is independent of aggregation. Whether you're aggregating or not, the suggestion is we use a couple of bits in some place to identify which cycle it belongs to. We've been trying to avoid that. That's tough.
It sounds like it would be really good for you guys to work offline, the authors of those last 3 documents, to work offline and see if they can come up with a consolidated document or maybe a recommendation on the best way to move it forward. But I do think that what I've heard is there's definitely more interest in the informational approach.
Yeah, I mean, just
we're definitely running tight.
Opinion from my side. I think, there is a difference between what we do on the requirement side, right? Whether we should have multiple requirement documents versus solutions, right?
Again,
So
please work with the authors and come back with a agreement. All right, so the next is on the Yang models. And because the other conversations ran long, you have less time.
Okay.
Please try to leave a few minutes for discussion.
Okay.
And you have like a total of maximum 10 minutes.
Sure.
Less would be better.
Yeah. This is Xuesong, and I will introduce the Detnet configuration YAM model update. And first, I will introduce the structure change about the new version. In the version 1, we defined the Detnet topology YAM model and the Detnet static configuration YAM model. And in the new version, the topology YAM model is unchanged, and we split the static configuration YAM model into two models. Detnet device YAM model, which is flow independent and common for all the flows, and then a flow configuration for the flow dependent configuration and as the output of the path computation. And after the data plan solution is stabilized, we want to define in the next step 3 more Detnet YAM models. And in the Detnet flow configuration YAM model, we have 3 configuration instances, which are Detnet service proxy instance, Detnet service instance, and Detnet transit instance. And these 3 instances are corresponding to the definition of the architecture draft. And the DSPI is for Detnet edge node configuration, which can map the client flows or application flows to the Detnet service in a particular domain. And the Detnet service instance is for Detnet relay node configuration, and it can enable or disable a particular function of the Detnet service. And it also configures the service path connecting the multiple Detnet segments. And the Detnet transit instance is for Detnet transit node configuration, which can build up a transit tunnel between Detnet service instance and also configure the queue's parameters. In the following slides, we will introduce the first 2 instance in details, and the Detnet transit instance will be defined after the data plan solution is most stabilized, because it depends on the data plan solution. And in the Detnet service proxy instance, we defined a list. It means for each edge node, there will be multiple DSPIs, and each DSPIs include a list of client flows and Detnet service instance and the mapping relationship between them. And the client flows, including the parameters of flow identification for differentiating client flows and traffic specification for flow filtering and shaping. And Detnet service instance includes in segment and out segment and their mapping relationship. The in segment includes the function defined in the architecture and data plan draft. And when the in segment is non-Detnet as the ingress edge node, sequence number generation function should be enabled. And if the in segment is Detnet at the relay node or egress node, the parameters will include incoming interface and flow identification in this node. And the out segment include the outgoing interface and the flowing identification for the next relay or ingress node. Also, it includes the Detnet transport instance. Oh, the picture on the right is the tree of our YAM model. And we think more parameters will be needed for the Detnet service functions. Just like for replication and elimination, we define different models, different mapping relationship models to do the configuration. Just like the right picture shows, if the packet elimination is enabled for a particular flow in a Detnet service instance, multiple in segments will map to one single out segment. And if in the next picture, if the packet replication is enabled, one single in segment will map to multiple out segments. And if both replication and elimination is enabled, multiple in segments will map to multiple out segments. And more parameters may be needed here, and it is also defined in 802.1cb. And perhaps we will consider reuse the parameters or give an interface to IEEE YAM model. And the ordering, which is also mentioned in the data plan draft, and there will be a parameter of ordering packet number, which means the maximum number of packets that are allowed to be buffered. The parameter is limited by the buffer size. And the Detnet inter-network function is defined in the data plan solution. And the flow identification is already covered by the in-segment content. And there are three methods of generating a sequence number: copy, translation, or regeneration. And we also have some considerations to deal with the flow aggregation. In the current solution, there are three methods of doing flow aggregation. Aggregation as an LSP, aggregation the Detnet flows as a new Detnet flow, or simple aggregation at the Detnet layer. All these three methods can be supported by the current configuration YAM model. And I won't go to details because of the time. The Detnet service YAM model is a new YAM model we added to the current version of the draft. And the three functions of replication, elimination, and ordering are different from the function parameters we just introduced, because these functions are capability for the device for all the flows, not for a particular flow. And it is to be decided whether these functions will be implemented in a device or in a particular surface. In a particular interface, sorry. And we also need some configuration
I'm
to...
sorry to rush you, but can you jump to the last slide?
Okay, sure.
Thank you.
Yeah, last slide, this one?
Yes, yeah.
Okay. And the top three things will depend on the data plan solution. And more contributions and comments are welcome. Perhaps we can ask for working group adoption. Yeah,
Okay,
that's
thank
all.
you. How many have read this draft? A little higher. So a few people. We have in our charter to have a Yang model for covering our work. So, and it seems that this document is emerging as the sole candidate. So I think the question that we really have to ask isn't whether we should adopt it or not. It's a question of when. The document's still maturing. There's pieces that are still going. I know I personally have some technical questions. But also, I think it would be reasonable to use this as a foundation for work. It would also be reasonable to wait to let it mature a little bit. And we'd like to ask the working group which of those two they would like. Do we want to adopt now with it being a bit rough technically, and then we'll have more changes during the life of as it progresses in the working group? Or do we want to wait until it's a little more mature before adopting? Those are really the two questions we're going to ask, and we're going to ask the whole questions because we're really over time, unless you feel compelled that you have to make the comment at the mic.
Can I make a question or comment about this?
Sure.
You always want to try to limit things to binary questions. I think my first question to decide on that would be, do we have a critical mass of authors to drive this forward? I think that's when I would like to adopt.
Okay. So thank you for the question. So the two questions we're going to ask are, do we want to wait for the document to mature a bit before adopting, or move to adopting now? So those are the two questions, and we're going to poll the room right now on that. So the first question is, how many think we should wait before adopting this document? Show of hands. So you want to see it mature a little bit more before adopting. So a couple of hands there, and not even really strong hands. They didn't shoot up. How many think that it's time to adopt and we can proceed and mature the document within the working group? Again, not a lot of hands, but clearly there's more interest on that side. So I think we'll take it to the list and look to do an adoption poll and see what comes out there. And to your question of whether or not we have enough people on it, that'll be something that we should bring into that adoption poll. As always, adoption polls can say, yeah, I support it, but I really want to see this thing done along the way. And if you want to, if that means more authors, sure.
No, I mean, I think this can take a long time as an IETF working group document. I think I would like to give the authors the safety that they're working on something that the working group really desperately needs. That would be my reason to adopt earlier. But in counterpart, right, we want the authors to be active.
Okay. So with that, we're going to move to Greg. Thank you very much.
I had one
please
question.
send it to the list. We can send it to. I mean, it's.
No, not about the process. About what we can put in the model.
Please send it to the list. I have technical comments too. I don't have time for. I'll send it to the list also. So Greg, if you can come in.
Okay, am I in?
Yeah, we see you, and you're allotted 10 minutes, but we have 15 minutes left in the slot, and we have two presentations.
Okay, we'll do my best. Okay, let's go next slide. Thank you. So this is just a reminder for people outside this working group if they want to interest what it is. And even though the replication elimination function being viewed as an optional, that doesn't mean that somebody can consider will consider implementation that doesn't support it. So let's go to the next slide, which concentrates more on what's been suggested as MPLS data plane encapsulation for the Detnet, and a quick reminder that the sequence number has a first nibble of 0 to differentiate it after the label, and associated channel header has a first nibble as 1, and use of GAL, well, for now it's for further study. So let's look at how proposed MPLS encapsulation for the Detnet works for OEM. And next slide, please. So this is a topology that had been used as an example of data flow with the packet replication and elimination subfunctions. And the replicating nodes are EN1 and R4, and nodes R2 and EN2 are eliminating nodes. And the numbers don't represent the labels, they just represent a path and copy number that arrives. Next slide, please. So let's consider how active OEM can perform and work with the proposed encapsulation. Elimination function obviously will use the sequence number information, which is a part of Detnet control word, and will use service label, S label, and first nibble identifying their control word. So if replication function can be envisioned using two approaches. One approach would be using the S label and decontrol word, and another option using just S label, the content. So if the first scenario, when their replication function uses two signs, S label and decontrol word, then active OEM will follow only the path through EN1, R2 to EN2. Why? Because ACH doesn't have, well, has a first nibble as 1, not as 0, so it's not recognized as decontrol word. And thus, packets of active OEM would not be replicated. Okay, let's go to the next. If replication function uses only S label, then replication works at EN1 and R4, but elimination doesn't work at R2 and EN2 because there is no sequence number information in ACH. So thus, we see that EN2 receives not one, but 3 copies of the same active OEM packet. So the conclusion and recommendation would be is that sequence information has to be part of Detnet encapsulation, which is not the transport encapsulation, because the proposed solution using the pseudo-wire. Oh, can we go slide back? The proposed is using the pseudo-wire as a transport, not as a service. And then the document talks about hybrid methods to using alternate marking methods and some other aspects. And again, this is the only first scope. So the next step that will be taken is extend Detnet requirements for OEM, consider active and hybrid methods to be used, appreciate the comments, and at some point look for working group adoption.
Yes, so we discussed in the previous discussions that we want to have a separate OEM document. And this seems to be a good start with a set of requirements. But I think the document should be developed further, and really contributions would be welcome as you suggest. And having a more mature document, we can start working group adoption a bit later.
Yeah. Yes. Again, what I wanted to stress is that from well, I'm the only offer for now, but I welcome anybody who wants to contribute. So that proposed MPLS encapsulation limits and restricts OEM, active OEM. So basically, there needs to be some adjustments done to MPLS encapsulation so that OEM, active OEM can explore and be in band with the data flows.
Greg, that fits in well with our call for greater review of the solution document. So sending those comments to the list would be very timely. Thank you. And with that, we really have to move on to the next.
Okay.
Thanks so much.
Thank you. This is Yuan Long. I will introduce a new revision of the REN topology jobs. First, as a scenario, the REN topologies have been very popular and typically deployed in the access and aggregation networks. This version mainly aligned with the newest architecture and data plane working group jobs. So we are using the PRF, that's a packet replication function, and the PEF, that's a packet elimination functions. So keep aligned. And we converged to a single solution. So we don't care about the internal implementations, anywhere the functions can be deployed, such as input interface, output interface, or centrally implemented. The multicast ring in the Detnet can be realized as this slide shows. The PLRF will replicate the multicast packets in two directions, in clockwise and counterclockwise to both directions. And leaves nodes will have both PLF and PEF, so the packets can be replicated in the same direction, and another copy will be sent to the PEF, so elimination can be done. Furthermore, we can also add the POF, that's reordering of the packet out of order substance. So anything can be done in the service node. If there are interconnection of rings, the same idea applies. We can see from this picture, the interconnection nodes such as I1 and I2 will have both PLF and PEF, so they can replicate the service in the same direction, and also do some packet replication, elimination. So only one copy will be sent to the second ring. So this is the same idea. The summary of this draft is, as we can see, multicast in Detnet ring will be highly resilient thanks to the Detnet architecture, and the service will be highly scalable. No matter how many leaves nodes are provided, we only need 2 copies of the packets. We will keep these documents aligned with in progress work group drafts and fill any gaps in the future. We would like to represent more work group feedbacks, and that's all. Thank you. Any comments?
Comments, questions? Out of curiosity, how many are interested in this work? A few people. How many have read the document? Notably more. Okay, thank you.
Thank you.
So we'll look forward to keep hearing how it develops relative to the actual data plane solutions.
Yeah, thank you.
Thank you. And with that, actually, now I just wanted to point out something I didn't point out before because he wasn't in the room. We have David Black here, who's our technical advisor from the transport area. We talked about him the last time and that we really appreciate him contributing. And you have 30 seconds if you want to say something.
Happy to be here. Hope I can do something useful.
Please go read the IP document. Tell us what you think. All right. Thank you all very much. Keep in mind that I know it's early to be thinking about Bangkok, but yeah, IETF 103, we're going to have that special meeting on Sunday. And keep that in mind as you think of your travel planning. And that's going to end tentatively right now. It's ending at 5 p.m. on Sunday. We'll start at 9 and have a break in the middle. It may move a little bit, half an hour, but certainly not beyond 5 p.m. And the reason why it's Sunday is because if we did it on Friday or Saturday, we basically had no participation from 802. And so it's unfortunate for us that that's the meeting where we're running this experiment where we're ending early, but it is what it is. If we want to have the meeting, it unfortunately has to be Sunday.
So can't we plead with them that as this is a rather a special meeting because we're finishing early, that maybe they could start one day so that, the pain is shared equally between the two teams?
unfortunately, we all volunteered to come here, and it's tough to. Go ahead.
This is as for the IETF, the meeting is arranged for years ahead, so it's not possible to change the meeting dates. As for the participation, that's why we had the different polls, which clearly show what's the difference between the expected participation of the 3 possible dates.
All right, thank you all very much.
Thank you.
See you in Bangkok.
It was closed for. Oh, it was a comment. It's okay, we're not taking this.
No, but if somebody wants to stand, you can go to another work.
Another word.
Yeah, but they can disagree. Yeah, that's the overload. So, yeah, that's. So again, it's something. But I think the same issue in terms of